So students, now moving ahead with the question of permutation and combination. Again, see, as I had been repeating again and again that I am trying to cover as many concepts, as many different type of questions as I can. So now read this question and then you will find that it's a question of de-arrangement. So what the statement, question statement says, number of ways in which 6 persons are P1, P2, P3, P4, P5, P6, we name the persons, can stay in 6 houses. Okay, the houses are named as H1, H2, H3, they are numbered as H1 till H6, such that P1 goes to H3, that means first person goes to house number 3 and none other goes to his or her home. Now see, when I am saying, or when it's written that none other goes to his or her home, what does that mean? That means, see, going through with the statement of the question, we can then conclude here that P1 person has his home as H1, P2 as H2, P3 as H3, and so on and so on. Okay, so let us write. So P1, P2, P3, P4, P5, P6. Okay, P4, P5, P6 has their house as H1, H2 numbered as H3, corresponding houses. Okay, H5, H6. Now what are we given? We are given that if P1 goes to H3, so that's fixed that P1 is going to H3. Okay, now in how many ways rest of the 5 persons from P2 to P6 can go to remaining 5 houses, that none of them goes to his or her home, her house. Okay, now that's a question of de-arrangement, but with a condition, and the condition is that the first person has to go to the house of the third person, that is S3. Okay, now before I start, we should know and we should remember the formula for de-arrangement. Now what is it? So if I have to arrange n distinct objects, so for n distinct objects, of course, so if we have to arrange n distinct objects, how many ways of arrangement are? So number of total possible ways of arrangement are n factorial, but here we have to de-arrange. What does de-arrangement mean? De-arrangement simply means that no person should occupy his or her designated position or place. Like in that question, there are 6 persons, 6 houses. Okay, and their corresponding 6 houses. If the question statement would have been that in how many ways 6 person can stay in 6 houses such that no person goes to his or her own house, that's de-arrangement. What I normally call it as perfect disarrangement. Okay, no person goes to his or her designated place. Okay, like again one more example, there are 10 letters and 10 address envelopes. In how many ways you can put a letter in envelope such that no letter goes to its own envelope? Okay, so that's de-arrangement, perfect disarrangement. No letter goes to its own envelope. Now what's the formula for n distinct objects? The formula for de-arrangement is n factorial times 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, and so on till you reach the last one, that is 1 by n factorial, and depending whether n is even or odd, you will get positive or negative sign here. Okay, now see, I always write this formula in entirety. Okay, but as you can observe here, these two terms they will actually get cancelled. Okay, so when solving the question, you can always start with 1 by 2 factorial. So that's it. So if I have to de-arrange 10 objects, so a formula will be, or the answer will be 10 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial dot dot dot. Since 10 is an even number, last will be plus 1 by 10 factorial. So that's it. So that's what we are going to use here. But as I said, it's not a direct question of de-arrangement. It comes with a condition, and the condition is it's fixed that P1 occupies the house of the third person. Now how to approach it? So my way of approaching it was, I said, okay, see, let us assign the third person whose house has been occupied by first person the house of the first person. Okay, why? See, why am I doing it? Because see, P2 has his house S2 left vacant, P4 has his house S4 left vacant, P5, S5, P6, S6. So remaining person P2, P4, P5, P6 has their own houses vacant, but P3's house is not there. Okay, but instead of that, P1 house is vacant. So I'm assigning that, okay, let us now consider let us now imagine that third person house is H1. Okay, now, so in that case, for remaining 4 persons, in how many ways? So I am sending for remaining 4 persons, number of ways of D arrangement. Number of ways of D arrangement. So I am sending person 1 to house H1 bachon. Okay, so that's your D4. So D arrangement for n objects is Dn. So D4, which will be 4 factorial into, as I said, 1 by 0 minus 1 by 1 factorial will get cancelled, 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Okay, now this is the case when P3 goes to his own house, when we are assigning H1 as his house, okay, and remaining goes to, none of them goes to his or her own house, okay. But in totality, if you see, P3 is actually going to the house of person 1, so it's D arrangement, okay. But the other possibility is, what if P3 doesn't go to H1. So these are actually two different possibilities. Either P3 will go to H1 or it will not go to H1. Now P3 not going to H1, as I said, we have imagined that now P3's house is H1. Okay, so now it's a D arrangement of 5 objects. P3 can't go to H1 and P2, P3, P4, P2, P4, P5, P6 can't go to their corresponding home. So now that is D5. So that is 5 factorial, 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Let's simplify it. So what will that give? So 120, 1 by 2 minus 1 by 6, 3 factorial plus 1 by 24, 4 factorial minus 1 by 120. Okay, so that comes out to be 60 minus how much? 20 plus 5 minus 1. So how much? 40, 45, 44. So D5 is 44. Similarly here, how much is D4 bachcho? So D4 is 4 factorial is 24. So 1 by 2 minus 1 by 6 plus 1 here. Okay, rather I'm sorry, 1 by 24 here. So it's 12. So it's 12 minus 4 plus 1. So 30 minus 4 is 9 here. So D4 is 9. D5 is 40. How much was that? 44. Okay, so therefore, since it's an either or situation, either P3 will go to H1 or P3 won't go to H1. So it's D4 plus D5. So answer is 9 plus 44. So that's a question of D arrangement, bachcho. So that's a question of D arrangement for today. Okay, so we have already covered questions based on inclusion exclusion principle, and then like divisors type of thing, and then ball box combinations also I think we have already covered. Okay, so now that was the question of D arrangement for today.